Hey, welcome back. Thanks again for joining me as you and I build chess. This time what we're going to do is work on building out the valid moves for pawn, which turns out to be a little trickier than all of the other pieces. So a pawn, we initially included the steppable module. So in previous episodes, we talked about inheritance and we talked about including modules to add functionality to a piece. And it turns out that pawns don't actually work like a lot of other pieces. And so we actually need to write a pretty interesting method here for pawn. So let's do that. Something's going on with Replit here where I need to probably reload. So great. So I'm going to remove steppable because we don't actually want to use that. Instead, what we need to do is we need a couple things. We need to know, like, for a pawn is like the only piece that can only move forward. It can't move backwards. Like all the other pieces, I think, can move both, forward or backwards in certain directions. And so for a pawn, we need to know if it's going forwards or not. So what we need to do is like say forward. Let's make a method called forward direction. And if the color is, I think if the color is black, then we want it to be like -1. Otherwise, we want it to be 1. So yeah, because when our board prints out here, so we have a board. Let's actually like re-render this board again and take a look at what we get. Oh, actually, we need board dot b equals board dot start chess. Okay, let's stop and then rerun it. When we print out the board, we need to figure out like if we have the black pieces on the top or the bottom, and then figure out sort of which index they are so that they can only move in the correct direction here. Right. Okay. So we've sort of we modified the initialization of pieces, but we didn't update our board. So let's go do that too. So we're going to do a little bit of catch up here. So we're going to pass in, I forget what we need to pass now. I think we need to pass in the board and the location and then the color. Board, location, and then color. So we need to pass in the board, so self, and then the location. In this case, we can say, yep, just 1C, and then the color, and then this one will be self 6C, and then the color. There's definitely a better way to do this. I'm just not remembering exactly the tricks to make this happen. So and then go 0, 7, 1, 6, 2, 5, and then 7, 4, 3, 4, and 3. So are we initializing our board correctly now with start board? Or let's see, start chess. And then we should be rendering out the board. Okay, great. All right, so black is on top, white is on the bottom. That means that when black is moving forwards, it should be going in this direction, which is increasing in the number in the index of this row, and then white should be -1. So let's make sure that we got that right. So back into pawn. So if it's black, it should be increasing. So I did get this wrong. Okay, so that should give us our forward direction for the pawn. And then the next thing we need to do is we have to implement we want to implement a method that has the same name as these slidable. So we want to implement available moves inside of the pawn here. And the available moves is going to be some sort of like combination, right? So if, so we kind of like a pawn can either move forward, like the default is like move forward 1, right? But there are also other moves where if you're on the start line, you can move forward 2. And then if there is an opponent that is diagonal to you, then you can also move that diagonal direction. If enemy diagonal, you can move that direction. So I think those are kind of the 3 different cases that a pawn can move around. So what we want to do, I don't think we're even going to actually use move directions because we need to sort of build up the available moves based on all these different cases. So we're going to say moves here is an array, and then we'll say moves here at the bottom. And so what we want to do is say like if the position in front, in the position 1 forward, so that's going to be yeah, let's just do this forward case, the forward case first. So if the position on the board one step forward is empty, so if the board at 1 forward is empty, then we can moves add 1 forward. So we haven't defined 1 forward yet. Sometimes I'll just like do this sort of fantasy driven development where I'll like try to write out what I want first, and then I'll go back and like figure out how to like actually make the variable what it should be. And so in this case, 1 forward is going to be let's see. So the direction, the x is always going to be the same. So it's going to be our current position, which is going to be like, let's see, like our current row and like, yeah, current R and current C is going to be equal to location. We have this location because that it's a instance method on piece, which is where we store the location where we're at on the board. So we have access to that location. We also have access to the board here. So we can work with either the location or the board while we're inside of this pawn class because it inherits from piece. So this will give us our current location on the board. And now the 1 forward step is going to be, it's going to be the same, it's going to be the row plus 1, right? So the current row plus forward dir, that's going to be like 1 step forward, and then it's going to be the same column, so current C. I think this is like 1 step forward. That should be the 1 step forward. And then we're checking like, is the board at 1 forward empty? And if it is, then we add it to 1 forward. And when you're a pawn, you can't actually take an enemy that's right in front of you, I don't think. I'm pretty sure you can only go diagonally. So this, I believe, is our 1 step forward. So this should work fine. We can also do 2 forward. So let's do 2 forward here. 2 forward is going to be the current row plus forward direction times 2. And then the same current column. And then this is actually going to be really similar, right? Like if 2 forward is empty, then we want to add 2 forward to our list of moves. Okay, so this is going to be our 2 forward. Notice that we're not updating the current row or the current column in this method. Okay, so then we need to check if there's an enemy diagonal to us. So how do we do that? Well, we need to, let's say, so we're gonna have a diagonal potentially up into the right, and we're gonna have a diagonal that's potentially up into the left. So if we just say, what do we want to say here? We want to say like diag left maybe is going to be the current R plus plus the forward direction, right? And then current C plus the forward direction. Or no, actually this can just be +1 because that should be like whatever, relative to one direction, and then the other is going to be diag right. And the row is going to be the same, but the column is going to be then -1. Okay, and then we want to check like if enemy at diag left, then we want to moves push in diag left, and then if there's an enemy at diag right, then we're going to push in 2 moves diag right. I think this might work. I don't know. The one case that we didn't already address is whether or not we're on the board still. So I think we need to also check to make sure that we're on the board. And I think that like one way that we could do that is just sort of like filter these out to see if we're on the board. Maybe we can do that here. Just say like dot select the move where board dot in bounds. I can't remember if we called it in bounds or in range. In bounds. Yep. So if it's in bounds, then of the move. So we only want to select the moves that are inbounds. Okay, I don't know. Let's check it out. Let's see if this works. So at this point, because pawn is getting so tricky, I do think that we need, in practice, I would write some automated tests for this, because we're like starting to get into territory where like things are going to get messy here pretty quickly. So let's say the board at 1-1, that should be a pawn dot available moves. So we'll print out the available moves for the pawn at 1-1. So that should be this one. And I think we should only have 2 available moves. We should only be able to move forward and move forward 2. Okay, undefined method square class for board. Interesting. So pawn line 12. So on pawn line 12, if board at 1 forward, the board should totally have that method. The board class has, okay, go back to board. We should have the getter method, right? Right here. We have that on board. Oh, what happened to our board? Oh, yeah, here. Class board, right? So this should totally work. This should give us back, okay, no method error, undefined method square root. Okay, interesting. Let's see. Oh, okay. I passed in self, and because we're in a factory function, so this is in a class method. So this is actually the class board instead of the instance of the board. So these all need to be changed to board. Okay, so that tripped me up because I thought typically self refers to the instance, but we are now in a class method, so we were talking about the class. So let's try this again. We were passing in that class and expecting that the board class itself had the square bracket operator, but it does not. It has an instance of it. Okay, available moves, undefined method empty for nil class. Okay, so let's go back to pawn line 12 and take a look here. Empty. Right. So that's asking, yeah, so I thought we had a method on the board, empty. Yeah, oh, so it's just empty. We don't actually like grab the location. So we would call dot empty like this and then pass in 1 forward. Okay, so that should work fine. Okay, this is another case where the null object pattern comes in handy. And again, I keep teasing this, but we'll come back to it. We will come back to it and check it out in a bit. All right, so we are executing something. I'm not sure why this takes so long. Okay, great. Let's print that out with a P instead of a puts. I think that might actually be right. 2-1 and 3-1. Yes, right? 2-1 and 3-1. I think that might be right. Which would be exciting because then we would have the available moves for every piece. Okay, so 2-1. So we are at 1-1, and then we can go to 2-1, and we can also go to 3-1. Great. So let's update our board here, and let's just put a new pawn at a position that has, or let's put a white pawn at 2-1 or at 2-2. 2-2 is equal to pawn.new, and we're going to pass in the board. We're going to pass in 2-2, and we're going to pass in white. So we're going to put a white pawn right here at 0-0-1-1-2-2. We're going to put a white pawn right here. And then the available moves for pawn 1-1 should include 2-2 now because we're going to have an enemy there. So we'll just test that out. And while that's going, I think we also want one at 2-0 to test the final case. Okay. So that did not, well, okay, let's see. Run. Oh, we're checking the available moves before putting the pawn in place, so we need to move that down here. Okay, stop, run. All right, so we're creating our board, we're creating the renderer, and then we're passing in, or we're creating 2 white pawns that are going to show up in front of as possible enemies of the pawn at 1, 1. So when we check 1, 1, we should see, great, excellent. Okay, so this pawn here can either move forward, it can move 2 forward, it can take this one, or it can take this one. I think there might be rules in chess where, like, if there's a move where you can take a piece, then you have to take the piece or something, but whatever, this is fine. Now let's also check the available moves for the piece that's right in front of this enemy, because it should have 0 moves because it cannot move forward. So that's going to be the pawn at 1, 3, or no, 1, 2. So the pawn at 1, 2 should have no available moves, I think. Three, 2. 3, 2. That seems incorrect, right? Because there's a piece in front of it. So it thinks it can move to, this is 1, 2, 3. It thinks it can move to this position. It cannot, so we have a bug. Let's go back to our pawn class. It can only move 2 forward if this one was not empty. So like if the board was not empty in front of us, then I think we want to say just return moves or something. Oh, the other thing is we didn't check if we're at the start line. Ooh, shoot. Okay. Yes. So if we're at the start line, then we can move forward too. It has to be empty at 2 forward, and it has to be empty at 1 forward. And we have to be at the start line, at start. Okay, so then we need to define what it means to be at the start. Def at start. So if we are, if the color is black and the row or column, let's see. All right, so let's also make a convenient method for the current R and current C, because we keep breaking out the location into current R and current C. So let's just make that a method on piece here. So we'll say def current R is at location.first. Def current C is location.last. And then we can come back into our piece, into our pawn class, and we can just remove this line. And then we want to see, like, if the current row, so if it's black, then in the current row is 1, then we're at the start. Or if the color is white and the current row is 6. So that should tell us whether or not we're at the start. And if we are at the start, okay, so yeah, so we're going to add 2 forward if we're at the start and the board is empty at 1 forward and the board is empty at 2 forward. This should give us really close. So that's looking good. I'm going to remove this. Okay, all right, cool. So let's run this again. And we should get no, I think we should get no available moves back, right? Okay, cool. So available moves is empty. That's what we expected. So everything is looking good. I think that available moves should now work for every piece. And again, in practice, I would probably write some sort of automated tests around this, but I think that's looking pretty good. So I think we've got this to do done. We've got make available moves work for a pawn. Yeah, I guess in the next episode, we can add some logic for actually moving around the board and taking a piece. Okay, so we'll come back in the next episode and talk about how we might move a piece on the board to a new position. Thanks so much for watching. We'll see you in the next one.